What we want to look at today is introduce what's called the chain rule, okay? The chain rule is a rule for differentiating things like this, okay? Because right now, if the only rules we had were the rules that we currently have, then the only way we could do that would be to use the binomial expansion, expand out the whole thing, and then take the derivative of each piece. And it would work, okay? It would work. However, there's an easier way, okay? And the easier way is by using this chain rule, okay? Now, the chain rule is a rule for helping us to differentiate composite functions, okay? Composite functions. And you guys know that composite functions are when we have a function that's within another function, okay? We have functions within functions. Now, the first thing that I want to do today is just practice identifying the functions within functions, okay? And I'm hoping to get to the point where you guys get this pretty quickly, and then we'll spend a little more time actually doing the chain rule. But I want to look at a composite function g of f of x, where we rewrite the f of x as just this value u. So our function could be written as g of u. Okay? So f of x is u, and then we just have a g of u instead. Okay? Now, in the function that we just looked at above there, notice u is this inner function. It's the function that's inside the other function. And really the way that I think is easiest to pick these out is think about if you were evaluating this function at a particular value of x. The last thing that you would do is kind of like your outer function. All right? If I were plugging a number in for x, I'd square it, I'd multiply by 3, I'd subtract 5, and then I would raise it to the 6th power. So this outer function, or the g of u, is just something being raised to the 6th power. So we would say it's u to the 6th. Okay? But what is the u here? 3x squared minus 5. Okay? So that's not too hard, right?
So you just choose the outermost function and identify that as g of u, and then u is everything else?
Yeah, u is what's inside of it. Okay? You can also think of this, guys, in terms of a lot of times it's a parent function. Okay? Here we have the parent function u to the 6th power, and then there's something else inside that parent function. Okay? I know u to the 6th wasn't one of the parent functions we learned, but you could think of it that way. Another one like this. We have y equals the square root of x squared plus 3x plus 5. So what is the inner function here? Yeah, x squared plus 3x plus 5. And the outer function, yeah, u to the 1/2. Okay, the square root of u. That square root is what everything else is inside of. Okay? Let's say we got this one. What's our inner function?
2x plus 5.
Good, 2x plus 5. And the outer function is? U to the 3rd. Good. Okay. Here's another one. What's our inner function? 2x cubed plus 3x. And our outer function? U to the 1/2. Are you getting the hang of this?
Yeah.
Okay. And there's another one. I don't know why this isn't. It shows on my screen, but it's not showing on your There we go. Okay. So now we have this one. Someone new, what's our inner function?
3x squared equals 5x.
Okay, 3x squared plus the 5x plus 1. And the outer function, u to the third. Okay? Now, why are we doing so many of these? It's very repetitive.
So we use the
They're
bit
going to get more complicated.
Well, they will, in a sense, get more complicated, but the fact of the matter is, if you can kind of identify these as two separate things, okay, then actually using the chain rule is helpful, okay? Is much easier, okay? Now, here's a couple more. I want you to try these, everybody to try these by yourself. Write your answers down, okay? Commit to an answer, write it down. Notice they don't necessarily use the u, but you could make f of x your u, and then this would be g of u. Well, let's just think about it. Take a minute. Just think about it to yourself so everyone else can think about it too. All right, let's see how we can do with these. Let's see, Tony, what'd you get for u on the first one? 3x plus 10. Good, 3x plus 10. Catherine, how about g of u? Good, u to the third power. Vicky, how about u on this one?
2x plus 4.
Good, 2x plus 4. And how about g of u? Good, u to the negative 1, or you could write it as 1 over u. All right, you see, it's 1 over. This is our reciprocal function. Okay? Were you able to figure that one out?
Oh yeah, no, I was looking at number 10. I've gotten T.
Oh, number 10? Okay.
Because there was like 2 of them. Like it could be to the negative third, but then when you do it, it's not drop.
Okay. So let's keep going then. Elsa? Okay, x squared minus 3x is our u, and then u to the 1/2, okay? U to the 1/2, or the square root of u. Okay, and it's good you guys are automatically, this is a good sign, you're automatically translating these things into exponents because you know that's what you're going to have to use to differentiate them. Okay? Now, what did you decide for u, Lexi?
I still put u to the, u,
Yeah, just u.
30x minus 10x squared. I just,
You just put the 10 inside there?
Yep.
Okay.
Just because they wanted a home. It's kind of like Mr. Dixon.
William, can you help us out?
We work together.
You work together on that one? Okay.
Okay, so instead that, so you do 10 over 3x minus x squared. And then u would be u to the negative.
Well, if you moved it up, what do you
Okay.
add?
That's not a bad thought. The only thing with that, okay, the only thing with that though is this. If you make this u to the negative third,
Over 10.
what?
Under 10.
Under 10?
Yes.
Okay. Well, wait. It would either be 10 over u cubed
Yeah.
or 10 u to the negative third.
Yeah.
That's what we need, because if you put the 10 with this, it's not being cubed.
Okay.
All right?
So yeah, so just that.
So yeah, so you'd have the 3x minus x squared, and then it's 10 over u cubed is your outer function, okay? And notice, by the way, you know how to differentiate this. In fact, guys, if you look at these, all the functions that we now see in front of us, we're able to find the derivative of, okay?
But
3u squared.
this is just splitting them up and then what?
Well,
You just
and
find the
then...
derivative of that and derivative of u, whatever.
Well, yes, that's where the chain rule then comes into play, okay? But if you guys can't do this pretty fluidly, then actually just trying to jump in and do the chain rule is going to be hard, okay? So, let's actually look at what the chain rule tells us, okay? Here's the chain rule, and we're going to look at it with both different types of notation, both the prime notation and the dy dx notation. If y is a composite function g of f of x, or we could write it as g of u, okay, then dy dx is g prime of f of x times f prime of x. Or if you want to use the u, it would be g prime of u times u prime. Okay? Now, let's take a look at the other notation, dy dx. Sometimes people think this one is a little easier to understand. Dy dx is dy du times du dx. In other words, the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. Now notice, when we do a derivative of something with respect to x, all of the x's just stayed x's in our answer, right? Well, here when we do the derivative with respect to u, all of the u's are just going to stay u's in our answer. In other words, when we take the derivative here and we get 3u squared, that u was 3x plus 10. It's going to be 3 times x plus 10 squared. It stays what it is. Okay? But then you have this extra step here. You're going to multiply that result by du dx. Okay? Now to put this kind of into words, dy du is the derivative of the outer function. Du dx is the derivative of the inner function. So this could just be stated as The chain rule is the derivative of the outer times the derivative of the inner function. Okay? So let's see how this works with the ones that we looked at before. The outer function here is something to the sixth power. What's the derivative of something to the sixth power?
Yeah,
5.
6 something to the fifth power.
All right, yeah, take the exponent, pull it out in front, 6 times whatever that was, and then 6 minus 1 is 5. Okay? Everyone with us on that? Okay? But the chain rule says we've got to go one step further here. We have to now multiply this by the derivative, the du dx, the derivative of the inner function. So now we're looking at just the 3x squared minus 5. What's the derivative of 3x squared minus 5?
6 to the first.
6x to the first. Okay?
Why though? Just because?
If you do AP or if you take calc in college, you'll go through the whole derivation. You know how we did the derivations on Tuesday using limits?
Okay.
Yeah.
I'm just
We
gonna
don't
say
wanna do
yes
that
for
with
now,
this.
and hopefully
So-
it'll be explained one day. One day.
All right, so then we have 36x. We should simplify what we can. 36x times 3x squared minus 5 to the fifth. Do not FOIL that out. Okay?
Took way too long.
All right.
That would just be awful if we messed up.
Yeah, but you guys know how to do the binomial expansion. It's not that terrible. It's just unnecessary.
I would still be crying.
Okay?
It's honestly all.
My hand
Does anyone have a question about what we've done here, though, on this first one? From this? Oh, you're taking the inner function is 3x squared minus 5, right? That was u. So the derivative of u with respect to x, 2 times 3 is 6, and then now it's only an x to the first, so 6x, and then the constant, the derivative of the constant is 0. So it's just 6x. Okay, that's what went right here. Okay. All right, let's keep going. We saw this one. You guys correctly identified the square root as the 1/2 power. Okay, so dy dx. What's the derivative of something to the 1/2 power?
1/2 x to
Two.
the negative 1/2.
F.
Wait.
What she said.
1/2,
X to the negative 1/2. Right?
the something, yeah, the x squared plus 3x plus 5 to the
Negative 1/2.
negative 1/2. Okay, subtract 1 from the exponent. Okay? Now, we're not quite done yet. What do we also have to put in here?
Multiply by the derivative of the inside.
Yeah, multiply by the derivative of the inside. The inside is x squared plus 3x plus 5. What's the derivative of that?
2x plus 3.
Yes, 2x plus 3. Okay? Is it coming a little bit?
It's getting better.
All right, what's confusing? What part?
How do you get the derivative of the inside vector?
The inside, guys, this is the stuff that, remember I was telling you, this is why we did a whole bunch of practice on Tuesday, which you aren't here for, that's probably why. We did a ton of practice of this on Tuesday, just factoring polynomials. So I would go back to those ones on Tuesday. If you look up the notes at the end, all the problems are on the PDF. But this was why I said I want you guys to be able to differentiate polynomials and those kinds of things in your sleep, because now we're having to do that within another process. Okay? So if you're still struggling with this, which I get why you two were asking about that, because neither of you were here Tuesday for the practice. Okay, that's okay. You'll catch up. If you're still struggling with differentiating this, then of course it's going to be a little overwhelming to do what we're doing now. Okay? The answer actually is this. I mean, if you want to simplify, what you could simplify would be, okay,
Well, it's okay. If you don't have to simplify, then I don't like simplify.
Yes.
well, here's the deal. All it would take to simplify this, and as far as really you would want to simplify this, would be to put the 2x plus 3 in the numerator, and then we have 2 square root of x squared plus 3x plus 5 in the denominator. Okay? That's all you would need to simplify that. Okay? Let's try to run through a couple more of these, okay? dy dx here,
Is 3,
3.
then parentheses 2x plus 5 to the second times 2.
2x plus 5 to the second power. There's the derivative of the outside. The derivative of the inside is 2, so we're multiplying by 2. So good, that's now 6 times 2x plus 5 squared. Okay? So, we are going to work through more of these tomorrow, but this is the idea. This is what we want to be able to do with the chain rule. Identify the outer function, get the derivative, then multiply it by the derivative of the inner function. One key here though, guys. One key. Notice in all of these, when you did the derivative of the outer function, the inner function stayed the same. Okay? It's not just an x. You don't put the derivative of the inside in the inside. When you're taking the derivative of the outer, the inside just stays the same. That's why it's dy du. The u, the inside, stays the same. Okay? Make sure you get that in your head right now so you don't start developing bad habits. Okay? All right. So, I think that's it.